Okay, so parallel lines, they have the same slope. Your symbol is this little line where you got basically two lines running side by side. And how you're going to see that on the paper is that somewhere, especially if you've got lines, some of these, they'll give you lines all over the place. And I remember this from back in geometry, they would have this, especially if you had like, 5 or 6 lines crossing. But somewhere on there, they'll put like A, those two lines, and then B. And that just means that line A is parallel to line B. So if you see that, that basically means that those two lines are parallel. Yeah, so that's the first thing we're looking at is parallel lines. Second thing we're going to talk about is perpendicular lines. Okay, and perpendicular lines, that's the lines that cross at right angles. They make an X or they make a T, depending on which way it's going there. So now here's the thing on this one. Obviously they're going to have different kinds of slopes on this one. But if you had two lines like this, again, just kind of keep it basic. What kind of slope would this line have? No, without the numbers, but it would just be a increasing or a positive slope. Am I okay with that one? The line going this way would be increasing or positive. The line going this way, that would be a decreasing or a negative slope. So when you talk about perpendicular lines, they're going to have opposite signs. They have opposite sign slopes. And here's the other thing. We're going to say they have opposite sign reciprocal slopes. So, again, if one's positive, the other one has to be negative. If one's negative, the other one has to be positive. And when we're talking about the reciprocals on these, here's basically your symbol. I mean, upside down T. So it looks something like that. And it'll kind of have the same thing. Sometimes they'll use, instead of letters, they'll use numbers. So they may do like 1, do the upside down T, and then the 2. And that just means that line 1 is perpendicular to line 2. And again, I'm flashing back to the geometry days. I know that sometimes, especially when you're doing those, you didn't see the perpendicular so much, but you should have seen that notation for parallel a lot of different times in geometry, because that was where you had to talk about your alternate interior, your alternate exterior corresponding, and your supplementary, and all those different types of correlations that you had between the angles. You always had to have some parallel lines in there somewhere for them to work up. So that was one symbol you should have seen a lot. This one now, you'll kind of see that more when we're going through some things. Okay, now here's the biggest thing you have to do. What we're going to do is, just to make sure we understand what's going on, I'm going to give you like a little T-chart here, with a 3-column chart. So I'm going to give you a slope. We're going to say that if this is your slope that you're given, then we're going to figure out what the parallel slope would be, and then at the same time we're going to figure out what the perpendicular slope would be. Because in the work you have to do for the 2.4, the last 3 questions that's in the homework that's online, honestly, that's the hardest part of what you have to do, is figuring out which one of these two and how much it's going to be. The rest of it's going to be exactly like we did on Friday, where you're going to take the numbers and just plug them into the formula and then just work it out and go from there. Okay, and we're going to do the first couple ones where we'll just give you the numbers, and then the second ones we're going to kind of go from an equation. But let's say that they said you're given a slope of 2/3. If they ask you to find the parallel slope, you don't do anything different. You give me the exact same answer. Be 2/3. Okay. If they give you this slope and then ask, okay, what is the perpendicular slope? Again, this is where you're going to change this sign from positive to negative. And whatever this slope is, do the reciprocal, flip it upside down, make it -3/2. Okay, for this one, let's say your slope is -1/4. And again, if they give you this slope and ask you what's the parallel slope, it's going to be the exact same number. It's going to be -1/4. If they ask you for the perpendicular slope when you're given this one, again, change it from negative to positive. Flip it upside down, make it 4/1. And if you can simplify this one, go ahead and simplify and just make it 4. Okay, for this one, let me do it a little different. Let's say this time, instead of just giving the slope, let's give you an equation. Okay, if you're given the equation, all you need for this thing is, all right, tell me what the slope is from this equation. So if you have this equation, your slope is 2. So then if they ask for the parallel slope, it's the exact same thing, that slope would be 2. They ask for perpendicular, again, change it from positive to negative. Now, sometimes people get a little confused, especially if it's been a little while since you've done some math on these. If that's your number, there are people like, well, how can you flip a whole number? Well, you have to make it into a fraction first. So the first thing is you've got to make it 2/1. Now that you've got it as 2/1, then you can flip it and make it -1/2. Okay, so just remember, if you do have something like that pops up, if you ever have a slope where it's a whole number, just remember that technically you can take whatever that slope is and put it over 1, so then you can flip it upside down to get the perpendicular slope. Alright, here's your trick question. And this is, again, where if you have your notes, it kind of helps out a little bit when we're going through these. Let's say they told you that the slope of the line was 0. Alright, parallel should be the exact same. Again, you don't change anything. This slope would also be 0. Oh, here's a really good review question, see if I remember. If it's 0, if the slope has 0, or if the slope is 0, what kind of line is it, vertical or horizontal? Somebody said it. It's got the zeros in it, right? 0 has a Z. Horizontal also has a 0, so that would also be a horizontal line. Which means this one also is going to be horizontal. What's perpendicular to a horizontal line? It's going to be vertical, right? So if you have a vertical line, that slope was either no slope or an undefined slope. And that's about the only ones where it might get a little tricky, where they give you 0 or undefined. And on those, remember that you're either talking about a horizontal line or you're talking about a vertical line. Again, that's kind of a good review question to help you remember what we did on Friday. So again, if it's 0 for a slope, that's horizontal. If it's no slope or undefined, then that means it's a vertical line. And again, I would just memorize 1 and just know that the other one is the other way. If I know that 0 is horizontal, then the other one has to be the other way. Just kind of remember those two. Okay, now here's what that whole thing is. Here's what we're going to do. I'm going to show you 3 examples of where they're going to ask you to write out the equation of a line, and you've got to kind of work through this one. So this is where you're going to have to put all this together to kind of see how this all fits when we're going through these. Okay, Okay, and they're all going to set up the same way. They're going to ask you to find the equation of the line that is parallel to y equals negative 1/2 x plus 7/2. That has the point for negative 2. Okay, now, and I'm going to do this kind of in a general form, and we're going to give you the steps, and then below this we'll come back to this one. So really should have put this first. So step 1. You've got to determine the slope of the new line that is either parallel or perpendicular. Because it's going to be one of the two. It's just going to change depending on the problem. Okay, and again, this part's where you're just going to look at the equation. We'll get that in a second. Let me give you the second step, and we'll come back and do both of these real quick. Second thing you want to do is, once you've determined what this slope is, use the slope from step 1. And the point that is given. And you're going to take those two things and plug it into the point slope formula. Okay, and again, that point slope formula, that's one we talked about on Friday. That was one we said if you don't know where to start, this is where you always want to start. This one's the same thing, that we're going to go back to that one. And again, this is that y minus y1 equals m times x minus x1. So that's what we're going to do. So it's almost the same thing we did Friday, where we plugged into that equation. The difference is today we have to do just a little bit of work to kind of get there. Okay, now here's where you get to be a detective to like the easiest case in the world. You got to look for the keyword, and it's either going to tell you parallel or perpendicular. So for number 1, we know we got to use parallel. And that's the one thing you're going to have to do. That's really the step 1. That is the most important thing you have to do is, all right, am I doing parallel or perpendicular? So for this one on step 1, we need parallel. This equation had slope of negative 1/2. So the parallel slope is going to be the exact same thing as here. It's going to be negative 1/2. Because if it says parallel, you don't change this slope at all. You bring this exact same slope down, and that's the slope we're going to use. Okay. The other thing they gave us was the point that was at 4, negative 2. And that's x1 and y1. And somebody's asked me before, they said, well, will they always give you a point? Yes, absolutely. Because if they didn't give you a point, it would be, are you ready for it? Pointless. Sad part is I've done this for like 15 years before that joke hit me one day. But anyway. All right, so here we go. So now you know what the slope is. Parallel means we're going to use the exact same slope that's in this line. And some people ask me, well, what about the other thing? It doesn't do anything at all. The other part of it, you just ignore it and be done with it. All you need is this slope and that line. And now we're going to plug those two things into this equation. So we can just kind of scroll everything up, and that's all we need. We need this slope, and we need that point, and that's all we're going to do. So that is y minus y1 equals negative 1/2 times x minus x1, which was 4. And same thing we did on Friday. If you have a minus negative in here, you have to fix that part first. Let's make that y plus 2. And that is x minus 4. Now, it kind of goes back and forth. They don't always ask for the same form. But if they ask you just for point slope, that would be your point slope answer. Sometimes they'll let you stop there, sometimes they don't. So we're going to go ahead and do both of them. That if they ask for point slope, you can leave it there. If they ask for slope intercept, that's where we're going to go ahead and kind of work this thing out. Okay, so for slope intercept, we have to do two things. Do distributive property with a 1/2. If you do a negative times negative, that's a positive. And again, if you do half of 4, well, half of 4 would be 2. And remember, you can just put that 4 over 1. Makes it 4 over 2, which would just be 2. Okay, and then the last thing you have to do is get rid of this 2 that's over here. Alright, if you have y equals negative 1/2 x plus 0, you can leave it there, but since it's plus 0, that adding 0 doesn't change that answer at all. So really, you could just leave it like y equals 1/2 x, and that would be the answer for slope intercept. So biggest thing on that one is just read and see where they want you to do. Sometimes they'll let you stop here. Sometimes they'll make you go to here. So just kind of read through, make sure that you see which way they're asking for. And again, really it's nothing different than what we did on Friday, where you're taking this information and you're going to plug it into this equation. And that's why we wanted to kind of break it up. Now, we'll do a couple more of these because there's one where we do perpendicular. And then there's one where it's a little bit different form that you have to kind of rewrite it and rearrange it, but it's still basically the same thing. Just got to do a little bit more work to get there. Okay, so for example 2, still going to do the same thing. Find the equation of the line that's perpendicular to y equals 3x plus 10. That has the point 6, 4. Okay, and again, you don't have to look very hard because you've just got to find the one keyword. In this case, it is perpendicular. So for that one, that means we have to change the slope. We can't use the same slope, so we've got to change it. So perpendicular means we have to change it. I can spell it here, perpendicular. There we go. Well, here's what we've got to do, is that y equals 3x plus 10. We were given y equals 3, or given that the slope equals 3. Now, and again, this is the hardest thing that sometimes people kind of catch on this is you've got to take the slope from here. So they gave us that the slope was 3. So to make it perpendicular, we're going to change it from positive to negative. And again, the slope is 3, it's 3 over 1. And then we're going to flip it upside down to make it 1/3. So whenever you have that equation, again, you don't care about what this number is back here. All you care about is what the slope is. If it's parallel, use the exact same slope. If it's perpendicular, you've got to change it from positive to negative, and you've got to flip it upside down. Now, we still have the 0.64, so we still got the x1 and y1 there. And then we're plugging it back in. So it's y minus 4 equals negative 1/3 times x minus 6. Now they ask for point slope. This one's okay because there are no minus negatives. So if they ask for the answer in point slope form, that would be it. Plug in the numbers and that's it. You're done. Now again, we're going to go ahead and do both because they're probably going to ask you to do, at some point in time, they're going to ask you to do at least both of these. So we'll go ahead and do them both just to make sure we get some practice. And again, for this one, we're going to do multiply out by the negative 1/3. Negative times negative makes that a positive. And again, if you do 1/3 times 6, the 6 is really over 1. So if you multiply straight across, that's 6 over 3, but you can divide and make that just a 2. Alright, now only one other thing to do. Add the 4. Okay, so back in of 2.4. Now that's all you're doing. So really, you're just plugging into this equation just like we did before. The only difference is you sometimes need a different slope than what they give you. If it's parallel, use the exact same slope. If it's perpendicular, you do have to change the slope, or you're going to change the sign and flip it upside down. All right, let me show you one more, because this is the worst case scenario of the hardest thing they can have you do on this one. And it's more of just that it's in a little different form, and you have to take it and rewrite it to a better form. So set that the same way. Find the equation of the line. So this one we'll do perpendicular again. So we'll go perpendicular to negative 2x plus 3y equals 3. That contains the point. Now, here's the worst thing with this one. The other two equations, they were already in y equals mx plus b form. This one, it's not in y equals mx plus b form, so we have to take this equation and we've got to rewrite it in y equals mx plus b form. Because you've got to figure out what the slope is. So from that one, sometimes people say, what's the number in front of x? Well, maybe, but you've got this number in front of y also, so it's kind of messing things up. So the easiest thing to do, just so you don't make any mistakes, is just take this equation we got and let's rewrite it in y equals mx plus b form. So we've got to get the y by itself. So we've got to get rid of this 2x. And since it's a negative 2x, we're going to add 2x to both sides. Okay. And again, they shouldn't be, anytime you're doing these, it should only be 1 or 2 steps. This one, you're going to add or subtract away the x. Once you're here, it's 3 times y, so we're going to divide everything by 3. So this will be y equals 2/3 x plus 1. Now again, key thing on this one is slope is 2/3. And again, what we need is not the same slope, but because it's perpendicular, we've got to change that slope from being 2/3 So if we need perpendicular for this thing, the perpendicular slope would be, change it from positive to negative, and then flip it upside down. -3/2. Okay, and again, they also gave us the point 2,6, so there is our x1 and our y1. Again, we don't care about the one that's here. I mean, it's fine that's there, but the only thing we really need from this equation is what's the slope. When our slope is 2/3, so if we're doing perpendicular to that, we're going to change it from positive to negative, and we're going to flip it upside down. Okay, and everything else we don't need it. All we need now is those 2 pieces of information. And we're going to plug it in to that equation. That's y minus 6 equals -3/2 times x minus 2. That would be point slope 1. Again, just for practice, we're going to go ahead and do both, because the more times you practice, the easier it gets. -3/2 times x is just that, it's -3/2. Negative times negative makes that a positive. And again, when you do 3/2 times 2, put that over 1, those 2's will cancel. 3/1 or just 3. Alright, and then one last thing, add the 6 to both sides. Okay, and that's the back end of 2.4. And again, that's a worst case scenario where they don't give it to you in y equals mx plus b form. If they don't, you just have to rearrange it so that you can figure out what the slope is. And again, everything on this one, it keys on what is the slope. And once you know the slope, then you can tell me the parallel slope or the perpendicular slope, which makes it really, really easy for what you're going to do for this thing. Okay, so that's more of just the 2.4 slopes. It's just more slope, more slope, more slope. What we're going to do is we're going to take about 10 minutes. Let me give you a preview of the last thing we've got to do, because I need to just show it to you today so you can see just a few minutes of it. And then tomorrow we'll come back into it and dig into it a little bit more. But I need to at least show you this just so that tomorrow when we get there, you'll have an idea of kind of what we're talking about for everything here. And this is, it's a little bit of 2.6, it's a little bit of 2.7, it's also, it's not exactly 2.8, but it's kind of getting up ready for 2.8. So we'll just say this is like 2.6 notes. And we're only going to do one graph, and then after that we're going to do just some shortcut stuff. Tomorrow we're going to do more with graphs with absolute value, but at least I want to just show it to you today, just show you what one basic one would look like. Alright, just a quick review though before we do this. What is the absolute value of negative 2? Just 2, right? Remember, absolute value just means you make it positive. Alright, what if the number is already positive? Trick question on that one. If it's already positive, you just leave it positive. So if you did absolute value of 2, it's still also 2. So either way you go, it's always going to be a positive answer when you come. And again, the absolute value is like the distance. It's how far is it from 0. Well, if I step 2 spaces to the left, that means I'm still just 2 spaces away from 0, so it's still just 2. So no matter what you do with absolute value, if you take the absolute value of a number, it's always going to be positive. If it's already positive, it just stays positive. Okay, so here's what we're going to do. We're going to graph y equals the absolute value of x, because this is the most basic absolute value thing we're going to do. But before we do that, we're going to make just a quick t-chart. Now the good news is, I'm not going to ask you to do this, but this is the only time I'm going to ask you to do a t-chart like this. Now you can do it on the test if you want to, but when we get to the test, I'm going to let you do a little bit of a shortcut to graph these, because there's a lot shorter, faster way to do this once we get past this basic shape over here. Okay, so we're going to start with the first number we had back here. We're going to start with 2. Again, the y is going to be the absolute value of 2, which we just said over here a minute ago that was 2. So when x is 2, the answer we get out of that is 2. Okay, we're going to go to 1. So y would be the absolute value of 1. Well, again, it's already positive, so it's just going to stay positive, so that's going to be at 1, 1. Then we're going to take the absolute value of 0, which is, again, just stays the same, it's still 0. So that's going to be the point 0, 0. Okay, if we do the absolute value of negative 1, kind of like we did back up here, if we take the absolute value of a negative number, it just makes it positive. So when I plugged in negative 1, that gave us an answer of positive 1. And then the last one that we'll do here is the negative 2. Which again, we kind of did that one back up here. We said if you take the absolute value of a negative, just make it positive, so that's the point. Negative 2, 2. Now again, you don't have to do this on the test. I'm not going to ask you to make out a chart and plug in all these different numbers, because once we do one of these and you can see what the graph looks like, we're going to take a shortcut and let you kind of see how we can do all these graphs with just a little shortcut, and you can just do it real quick and real easy. Just do a few things with it. Alright, now if we graph that, and I'm going to see, I think we can get the graph right here in the corner. I'll put it right here. Because you really don't need a lot below the line, we just need a couple of spaces above the line. Okay, so the first point was at 2, 2. Next point was at 1, 1, 0, 0. We got lines that look something like that. Okay, and for the absolute value, all we're going to do is we're going to connect the dots. They look something like that. And here's the one thing I want you to kind of take away from today when we talk about these, and we'll talk about this more tomorrow. But anytime you do absolute value, the graph will always be a V-shaped graph. every single time, no matter what you do. Doesn't matter what the equation is, no matter how they do to it, if they put absolute values on it, it's always going to be a V-shaped graph every single time. So that, and again, that's the only graph we're going to do today. Tomorrow, all I want you to do is when we start doing more graphs is just get you to think back to this one that's going to be V-shaped. Here's the one thing I want to show you, and then this is the last thing that we'll do here. They're going to ask you to translate. Now, and when we talk about translations, we're not talking about English to Spanish or Spanish to English. This is more of, when I talk about translations of graphs, when I talk about translations, that really means you're just moving them or you're shifting. So if you've got that picture of the V-shaped graph in your head, here's basically what we're going to do. There's two ways you can move the graphs that we're going to kind of key on. There's a third thing tomorrow that's more like with slope, but we'll talk about that more tomorrow. If you add or subtract outside of the absolute value, you translate, you shift, you move. We'll just say shift for now. You shift the graph vertically. Again, vertical means you're going up and down. So here's the thing: if it's, we'll just put it out inside of here. If it's positive, if it's +2, you're going up. If it's -2, you're going down. So if you have a plus sign on the outside, that means you're going to move the graph up. If there's a minus on the outside, that means you're going to move the graph down. Which means all we're going to do is we're going to take this V shape, and we're just going to keep this V shape that we have, and we're going to move it up or we're going to move it down. That's all we're going to do is just move this thing up and down. Okay. The other big thing we have, and this will be it, and we'll show you a couple of quick examples, is if you add or subtract on the inside of the absolute value. You're going to shift it horizontally. Now here's the one catch to that one. When you do shift it horizontally, it's going to be in the opposite direction. Again, if we're talking about horizontally, that means you're going left or right. Okay, now here's the opposite part of it. If you look at the number, we don't have a number line up here. Well, kind of sort of do. Where are the positive numbers on the number line? On the right. So on this one, it's going to be the opposite. If you have a positive number, that means you're actually going to go to the left. Where if you have a minus number, you're going to go to the right. So anytime you put a number that's on the inside, it always makes it go in the opposite direction. So if it's on the outside, it's vertical. If it's on the inside, it's horizontal. But it's in the opposite horizontal direction. Okay, now, again, with this one, we're not going to graph it. Here's something. If you can get the basic idea on this one, we can start graphing these tomorrow and be okay. So this is all I want you to do for right now. Is I'm just going to have you describe the translation of y equals absolute value of x. Again, this one, if they give you problems like this, it's really straightforward, really easy, not getting real complicated. Just want you to have the basics of it. You've added a 3 on the inside. So this one, this is where they're going to tell you you're going to move it 3 units, and then you got to tell them if it's 3 units up, down, left, or right. And again, on the inside means you're going to have to move it left and right, but it's kind of opposite signs. So in this case, it's a +3, so that means you're going to move it 3 spaces to the left. So if we had this graph, we would take this graph and scoot it over 3 spaces this way. So we go 1, 2, 3. We put this graph over here. So it would look something like that. Okay, and that's all they're trying to get you to see is that when you start adding numbers to this, where you add the number tells you which way to put it. If you put the number on the inside, you scoot this thing left and right. If you put that number on the outside, okay, absolute value of x minus 4. Well, we know we've got the 4 right here. So it's going to be 4 units, spaces, whatever you want to call it. But it's on the outside, so it goes in the way you normally would think this is going to be 4 units down. Okay, so if you do absolute value of x minus 7, where that 7's on the inside, again, we're back to this part where we're on the inside, so we're going opposite direction. So normally we would think 7, the negatives would be on the left, but we're going opposite. It's going to be 7 units to the right. All right, and one last one. Give you 2 numbers, one inside and one outside. Okay, one on the inside again, we're going to make it go left and right. So it's on the inside, even though it's a +2, that's opposite, that's going to be 2 left. The 6 that's on the outside, that means it's going to go up or down. In this case, it's positive, so it's going to go the way you normally think it would. That's going to be 6 up.